In this chapter, we are going to begin our exploration of conics. So what's going on for a conic, as you can see there's this picture over here, but I'm going to try to recreate it, is that we're going to have this center line right here, which is going to be called the axis. Now with the axis, we are going to have another line that is going to intersect it. And then for this line that's going to intersect this axis, what we're going to do is we're going to, whatever this angle is right here, we're going to maintain that angle and then imagine kind of rotating it around this axis. And when we do that, we're going to generate these right circular cones. There's going to kind of be this upper cone and this lower cone. These two cones that are formed are actually called naps. So there's going to be the upper nap and then the lower nap. This line that we started with, that we ended up doing that rotation around, that is called the generator. And then where that line met that axis right here is called the vertex. Each of these cones has a base. Okay, so this would be then the base for that cone. And then this region up here would be the base for that upper cone, or that upper nap. So this is kind of our starting or our basic figure, and then what we're going to do with that is we are going to take that and we are going to intersect it with a plane. Okay, and a plane can just be thought of as like a sheet of paper, right? So it's just a flat two-dimensional surface. So conics, which is an abbreviation for formally saying conic sections, are the curves that are going to result from the intersection of a right circular cone that's going to have these two naps and this plane. And when you do these intersections, there are 4 different things that could result. So circles will result when the plane is perpendicular to the axis of the cone when it intersects. So if we look at this first picture right here, here would be an example where the cross section will form a circle. Right, so this plane will intersect that cone at a right angle. Perhaps another way of thinking about what's going on there is that plane will be parallel to the base. Okay, so as a reminder, you can, for instance, think about this as the base, okay, which is going to be parallel to that upper base. Now, we talked about circles a little bit earlier in this course, so maybe let's just remind ourselves about what's going on with the circle. All right, so when we talk about circles, we were talking about it having a center HK, and it had that radius R. So then we had the equation for circles as being x minus h squared plus y minus k squared is equal to r squared. All right, so we kind of looked at circles earlier. Circles are one of the conic sections. All right, so other than circles, what else can we form? Now, for this next one, an ellipse will be formed when that plane is tilted slightly. When it intersects the cone. So in this next example right here, this next picture, here would be an example of an ellipse. Okay, so that plane is not parallel to the base. Okay, so ellipses are kind of like squished or elongated circles. So we're going to talk about the fact that they have a lot of properties relating to circles, and in some cases circles actually are considered to be like a special ellipse. The other thing that could happen is creating a parabola, and that can happen when the plane is tilted farther so that it is parallel to one of the generators. All right, so remember the generator was that line that we spun around in order to form our cone. Okay, so there's actually a whole series of generators because every time you move it, wherever that line goes is considered to be another generator. All right, so if we look at this, here would be an example of a parabola. And then what's going on, if you look at the plane, it will cut from the side down to the base. So we've already looked at parabolas earlier in this course, but we're going to now approach them from a kind of a new idea about looking at them as one of our conics. And then the last thing that you could form is a hyperbola, and that's when the plane will intersect both parts or those naps of the cone. Okay, so you can see it's going to intersect this upper nap and this lower nap. Okay, so this one is your hyperbola. And it will cut from one of the bases to the other one. Right, so it goes all the way from the upper base to the lower base, and it intersects the cone. Now there's some degenerate conics, which is what would happen if the plane intersects that vertex somehow. In those cases, you either get a point, a line, or a pair of intersecting lines. So we're not going to really spend a lot of time looking at the degenerate conics. We're going to look a lot at these four flavors, and specifically we've already looked at the circle, so we're going to spend some time looking at the parabola from a conic point of view, the ellipse, and the hyperbola. Okay, very cool. So the first one we are going to explore is going to be the parabola. Now, to form a parabola from the conic point of view, what we're going to do is we're going to have a line and we're going to have a point off to the side. This line that we're going to start with is going to be called the directrix, and the point off to the side is going to be called the focus. All right, so maybe just to show you just a very, very generic case. All right, so let's maybe call that my starting line. That's my directrix. And let's put a point. It's going to be called my focus. And then from there, we're going to build a parabola. Now how we build the parabola is going to be a little bit special, and we'll explore that more in a moment. But first, let's go back, all right? Because we've already talked about parabolas a lot in this course. So I think it helps to maybe review what we've already seen and then talk about where we're going. So we have this general form for your parabola is y is equal to ax squared plus bx plus c. So these are the parabolas that we've explored earlier. This is going to be a function. If we look at the graph for these ones would either open up or down, right, depending on whether or not that a was positive or negative. You could have a parabola that opens sideways. In that case, it's not going to be a function, but it could open sideways. And what that would look like, it would be x is equal to a y squared plus by plus c. So in this case, then this would open either to the right or to the left. And then the y variable is squared as opposed to the x variable. Right, so that's going to be really important to remember. If the x is squared, those ones open up or down. If the y is squared, those will open either to the left or right. All right, then from there we started talking about this vertex form. So the vertex is like the very, very special thing about a parabola. So, you know, for lines, we always want to talk about its slope. For parabolas, we would want to talk about its vertex, all right, that very special point where that line of symmetry, or that axis of symmetry falls. So we could write this in vertex form. We did that by completing the square. So we get this vertex form is equal to y is equal to a parentheses x minus h squared plus k. And then again, if this was going to be a sideways opening parabola, this would look like x is equal to a parentheses y minus k squared plus h. So I want you to start noticing for the vertex that the vertex, which is that hk, the h will always kind of stay with this x, and the k is going to stay with the y. So the new thing that we're going to be looking at right now is going to be looking at a parabola, but in a conics format. And that's going to look like 4p parentheses y minus k is equal to, and then in the quantity of x minus h squared. If this was a sideways conic, it would look like 4p x minus h is equal to y minus k squared. Okay, so we can continue to see even in these conics forms that the h is always with the x. The y is always, the k is always with the y. And in this conics form, this new variable right here, this p, the p is on the unsquared part. All right, so what I mean by that is here's the squared part. Here's where the p is. Over on this other one, the sideways one, here's the squared part. The p is on the other side. All right, so it's always on that unsquared part. So let's talk about how these forms are going to be related to each other. Y is equal to a parentheses x minus h squared plus k. Let's subtract k from both sides, so I get y minus k is equal to a parentheses x minus h squared. I'm going to get this a out of there by multiplying both sides by 1 over a. So I'm going to have 1 over a times y minus k is equal to x minus h squared. And then that's just going to get us to our conics form, 4p y minus k is equal to x minus h squared. All right, so what's going on here is 4p, right, this expression that's going to come out in this conics form is going to be equal to 1 over a. All right, we're just going to say that these two things are equal to each other. Which means if I solve this for p and I multiply both sides by 1/4, p is equal to 1 over 4a. Now, why do I care so much about this new variable? Well, this value for p is very cool when we look at things from a conics point of view. All right, we really like this. What this variable is going to tell us is p is going to be the distance between the vertex and the focus. Okay, so remember, we're dealing with parabolas. The parabola is still going to have a vertex. So this value for p is going to be the distance between the vertex and the focus, but p is also going to be the distance between the vertex and the directrix. Right, that line. So maybe coming back up here to my picture, if here's my focus and here's my directrix, right here, halfway between them, is going to be my vertex of my parabola. And then from here, we're going to be able to build our parabola, and it's going to satisfy a very, very cool and important distance property relating to the focus and the directrix. That's what we'll talk about in just a moment. So let's talk about what's going to be happening on an example that we have seen previously, and how these distances are going to end up being a very important part of our conic exploration. So let's go ahead and graph this parabola. Y is equal to 1/8 parentheses x minus 3 squared and then plus 4. All right, so this is in the vertex form that we are familiar with seeing, right? So this y is equal to a parentheses x minus h squared plus k. So my vertex is going to be at hk, which for this problem is going to be 3, 4. One of the other things that we looked at when we were graphing these is the axis of symmetry. All right, so in this case, the axis of symmetry is going to be x is equal to 3. Another thing that we looked at is this value for here for a, which is 1/8. It's greater than 0, so it's positive, so we know that the parabola will open up. Okay. And then from here, we're able to do some graphing for this. All right, so we'll start graphing this. So we'll come over here. All right, put down a couple axes. So I know my vertex is going to be at 3, 4 and opens up. So we're going to be dealing a lot with that first quadrant. Don't really need to worry about the other quadrants so much. All right, so 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Okay, so 3, 4 is where I'm supposed to have this vertex. And I know that this thing is going to open up, right? So I'm not going to do a lot of very fancy things on this graph, because where this is going to be just kind of an exploration about some of the things that's going to be going on with this value for P and this focus and this directrix, right? What is all this stuff that we're looking at? Okay, so this point right here is our vertex. So P is the distance from the vertex to the focus. And from what we just talked about up here, this value for P is going to be equal to 1/4a. So in this problem, my a is 1/8, so I'm going to have 1/4 times 1/8, which is 1/1/2, which is going to be equal to 2. So this value for P, this distance from my vertex to my focus, is going to be 2. All right, so I'm going to go up to right here. This is the distance for P. And then this point that I just got right here is my focus. So what is that focus as an ordered pair? All right, so remember that the vertex is at 3, 4. So to go from my vertex to my focus, I'm not going left or right, right? So there's going to be no adjustment to my x-coordinate. Right, that's going to stay at 3. What's going to happen though is for this y-coordinate, I'm going to add this distance. Right, so I'm going to add this value for P. So my focus is going to be at 3, 6. We're going to be talking about this a little bit more in some of our other examples, but one of the things I just want to point out right now is that this value for P is positive. So that means that we're going to go up from the vertex to the focus. So if we were to look at a computation and my value for P was going to be negative, that means then from my vertex I would go down to my focus, and then I would have a downward opening parabola, right? But that's not what happened here. My P value is going to be positive, and then this thing's going to open up. Now, I also said that P not only was the distance between the vertex and the focus, but it's also the distance between the vertex and the directrix. So what's going to happen here is this value for P, if I go the other way, it's going to get me, I'm going to do this in the same color, we'll dash it, this right here is the directrix. Okay, so if my vertex is at 3, 4, so the y-coordinate was 4, and I'm going to go down 2 on the y-axis. The equation for my directrix is going to be y is equal to 2. Okay, so we've got these new ideas about a focus and a directrix. There's going to be a last new idea that's going to be looked at when we think about parabolas from that conic point of view. And the last idea is going to be looking at something called the latus rectum. Right, so as opposed to calling it the latus rectum, I've sometimes heard it also referred to as the focal width. Now what this is, going up to my picture right here, the latus rectum, or that focal width, is going to be on from the focus. All right, so this is why sometimes it's nice to call it the focal width, because it has to do with the focus. So from this focus, we are going to extend it, and it's going to be parallel to this directrix. Right? We're going to extend that out until it hits my curve. And then this segment is called the latus rectum. So the latus rectum is equivalent to 1 over a, and as a reminder in this problem, a was 1/8. So 1 over 1/8 is just going to be 8. But 1 over a is equivalent to 4p. As a reminder, p was equal to 2. So what's going on is the length of the latus rectum is equivalent to 4p. So when we're doing things from this conic point of view, everything is talked about in terms of this new variable p. Okay, so the length of this latus rectum is 8, which means this piece right here is going to be 4, and this piece right here is going to be 4. So the length of the entire thing ends up being 8. So we can go get those ordered pairs, right? So this ordered pair right here is going to be my focus, and then plus this distance of 4, right? So that's going to be at 7, 6, right? So same y-coordinate, I'm just moving my x-coordinate. And then this point over here is the x-coordinate of my focus, which is 3, and then minus 4 units away, so that is actually going to be at -1. Right, so at -1, 6. So you can see my picture is a little off from my sketch because it should have been over here past the y-axis, right? But I can get these two new kind of points, these special points that fall on this latus rectum. And when we go to do these graphing, this vertex and these 2 points are going to be the special points that we're going to be using for our graphing purposes. All right, so that was a lot, but just to try to show you what's going on with what we were seeing before and the new ideas that we're going to be introducing as we analyze parabolas a slightly different way. So before we look at some examples, let's kind of summarize everything that we've been seeing and talking about, and then we'll go and apply it in a couple of problems. So our formal definition of a parabola, as viewed from the point of view of a conic section, is it's the set of all points in a plane equidistant from a fixed point F called the focus, and a fixed line L, the directrix, that lie in the plane. So this idea about equidistant, that it has to be the same distance from the point to the focus, and then from the point to the directrix. That's a big idea. So let's see what's going on there. Alright, so do a quick sketch. Here will be my directrix. Here's my focus. Here's just a rough sketch of a parabola, and right here would be the vertex of that parabola, right? So what's going on with this distance idea is this distance from the parabola to the focus, that is the same distance from the parabola to the directrix. And that relationship holds true for any point that's on this parabola. So for instance, at this point right here, the distance from this point to the focus is the same as the distance from this point to the directrix. What if it was this point up here? Then the distance from this point to the focus is the same as the distance from this point to the directrix. Okay, so that's why the focus and the directrix are very, very special when you think about this in terms of a conic section. Alright, so some of the other vocab then. The axis of symmetry of the parabola is the line through the focus that is perpendicular to the directrix. Alright, so here would be, this picture over here, the axis of symmetry. So notice that it also contains the vertex of the parabola. The vertex of the parabola is the point of intersection of the parabola with that axis of symmetry. The vertex is on the axis of symmetry halfway from the focus to the directrix. So coming up here to this picture, whatever this distance is, half of the distance is right here, and then half of that distance is right here. And what we were saying before is this distance is actually going to be what that value for P is. When we're working with these conic sections, perhaps one way that will help us keep clear of everything that's going on is to keep in mind that for all conic sections, they will quote-unquote eat their focus. So looking at this sketch that I have up here, for whatever way this parabola is going to bend, the focus is going to be inside of the bend. We're going to find that that's actually true for all conic sections, so it's just a good thing to keep track of right now. Alright, so let's look at some just general structures for these things. If the x term is squared, so right here x minus h squared is equal to 4p parentheses y minus k. So if the x term is the one that's squared, in these cases this will open up or down. Just as a side note, your book uses A right here as opposed to P. I don't like using A because as we were looking at this previous example up here, A actually does have a very special meaning in parabolas that we've already explored before. So I don't want to get that A with parabolas confused with this new value. Right? So that's why I like to use P instead. So when we're looking at these, you need to pay attention to which variable is squared. So if the value for P is positive in this case, so sketch our really quick coordinate axes here. X and Y, and just to kind of make things simple, let's just go ahead and sketch this parabola opening up through the origin. Alright, so for whatever value that we get for P, remember from the vertex you're going to go up P units if P is positive, right? And then that will get you your focus F. If you go down P units, that will get you the line for your directrix. Okay, so we said if P is positive, this thing will open up. And then this distance right here from the focus out to the parabola, that distance is 4p, and that is the length of the latus rectum, or that focal width. Notice that the focus itself is not on the graph. Right? So it's an important point, but it's not on the graph. The vertex will be on the graph, and then these 2 points will be on the graph as well. So when we're graphing these things, we're not going to be graphing using the key points anymore, like we did earlier in the course. So nope, not using key points anymore. We are now doing 3 points to graph these. So the vertex is still going to be important. Still going to need to find that. But from there, we are going to then use the focus and specifically that focal width along with the focus to get our 2 additional points. Okay, so these are going to be then the 3 points that are going to be special for us. The vertex, and then these 2 additional points that fall on this line segment through that focus. So for this one, if x is this variable that's squared, but the value for p is negative, that one will open down. All right, so let's sketch that real quick. All right, so put in our x and y axis. Again, we'll just make this easy. We'll just orientate this at the origin. So I'm going to have a downward opening parabola. Whatever this distance is that I go down from the vertex to get to the focus, I'm going to repeat that distance on the other side. That will get me the directrix. And then from the focus, extending that out till it gets to the point for the parabola, that distance overall is going to be 4p. So half of the distance, or 2p, is going to be over there, and then half of the distance, 2p, is going to be over here. Alright, so looking good so far. Now let's go and analyze it if the y variable is the one that is squared. So in those cases then, they're going to open left or right. Now I have these different formulas over here, but as opposed to memorizing them, it's probably just going to be way easier and will help aid your recall if you just work with the graph, analyze the relationship between all these pieces, understand what the focus is, what the directrix is, and all these distances that need to be satisfied, and that's how you can kind of uncover all these different pieces. Alright, if you try to memorize all these things, you'll just forget them. Okay, so then I will have, so if p is positive, or p is greater than 0, that one will open right. So again, just to make our life a little bit easier right now, I'll just have it going through the origin. Right, so for whatever this value for p is, that I'm going to go out to the right, that will get me my focus. Repeat that value for p on the other side. That will get you the directrix. From the focus, in this case, as opposed to going left and right, we're going to go up and down. And again, this distance overall is 4p. And then that is the focal width, and then that gets me these other 2 points that would be on my parabola. Finally, if P is less than 0 or negative, that will open to the left. All right, so sketch some axes in here. So X and Y. So leftward opening parabola. All right, once we know that value for P, that will get me to my focus. Okay. Go the other way. Gets me the directrix. From the focus, extend it up and down till it intersects with that parabola, and then that is the focal width. And then again, if the whole distance is 4p, it's split into half. That 2p is the length above, and then 2p is the length below. All right, and then notice again for every one of these conic sections that the way that the parabola opens, the focus is always going to be inside that parabola, so it's going to eat that focus. All right, and then notice again in all these examples that the vertex is halfway between the focus and the directrix. All right, so let's take a look at some examples. All right, so here's going to be our first example. So we're going to sketch the graph of this parabola, find its vertex, focus, and directrix, and find the 2 points that define that latus rectum. So the equation is x squared is equal to negative 3y. All right, so some things to kind of notice right away is notice that since the x is squared, we know that those will open either up or down. On the side opposite my squared variable, that is where I'm going to find that 4p value. Right? So just as a reminder, in general, this would look like x minus h squared is equal to 4py minus k. So this one, the other thing to notice that there's nothing being added or subtracted, so maybe let's talk about that next. Nothing is added or subtracted, right, inside of where those variables are. Okay, so if I think about those as being translations, this is not moving from the origin, all right? So it's vertex hk is going to be at 0, 0. So whatever is sitting opposite the square term on the other side in front of that variable that's over there, in this case it's going to be y, that's where you're going to be able to find that value that's going to be equivalent to 4p. So for this particular problem, 4p is equal to negative 3. Solving for p, we get p is equal to negative 3/4. All right, so since p is negative, we can go back up here, okay, and I know that this now has to open down. So let's sketch what I have so far before we worry about getting that focus or directrix. All right, so I need to 0, 0, and I want this to open down. And I'm going to be moving a distance of negative 3/4, so I'm not going to be moving all that much from the origin. Right, so I'm going to be here, so maybe 1, 2, 3, 1, 2, 3, maybe go 2 up there. Just go ahead and sketch this. I know this is going to be opening downward. Okay, I might have to adjust it later, but I'm just trying to get my bearings on what's going on here. All right, so this value for p is important because from this vertex, we're going to go down 3/4. and that's going to get me my focus. And I'm going to go up 3/4. And then that's going to get me my directrix. Alright, so now getting this directrix is pretty easy. Okay, so its equation is going to be y is equal to 3/4. Alright, this focus isn't going to be too terrible either. Right, maybe I'll put that in red. Okay, so for my focus, alright, so at this point in time, from my origin, I'm just going to go down 3/4, so that's going to be at 0, -3/4. Alright, so finally let's go get the 2 points that are going to be on that lattice rectum, or that focal width. So the focal width is 4p. And in this case, this is just going to be a distance, so I don't have to worry about p being negative. So I just can do 4 times 3/4. Okay. So the focal width is going to be 3. So from here, which this is going to be my axis of symmetry, right? So from there, I'm going to go half the distance to the left and then half the distance to the right. So we're going to split that in 2. So I get 3/2. So meaning from my focus, I'm going to go 3/2 this way, and I should get a point that's going to be on my parabola. And I'm going to, from my focus, go 3/2 this way and get another point on my parabola. So from my focus, I'm not going up or down. Right? So this is going to, both these ordered pairs that I'm finding are going to have a y-coordinate of -3/4. That's the same y-coordinate as my focus. What's going to change on these 2 points is going to be their x-coordinate. So since my focus had an x-coordinate of 0, if I go 3/2 to the left, I'll be at -3/2. And then if I go 3/2 to the right, I'll be at +3/2. Alright, so we found everything that we needed, right? We have a sketch of the graph, we found our vertex, we found our focus, we found our directrix, and then we found these 2 special points, so these ordered pairs. Maybe I'll just write them down here. It's -3/2, -3/4, and +3/2, -3/4. Alright, so on this next one, let's take a look at something where the vertex is not going to be at the origin. All right, so we have the equation y + 1 squared is equal to -12 times the quantity of x + 2. Alright, so a couple things to first notice. So I want you to notice that the y is squared. So in the cases where the y is squared, those ones will either open left or right. So this one specifically, that value for 4p is found on the other side of the squared term. So in this case, it's going to be -12. Dividing both sides by 4, we get p is equal to -3. So since this p value is negative, then that means that I'm in the case where it's going to open left. Alright, so we have a leftward opening parabola. So for my vertex, remember k is always going to be associated with the y variable, and h is always going to be with the x variable. Right, so in this case, my vertex is going to be -2, -1. So it's going to be easier to get the other pieces of information if I start sketching what I have so far. Alright, so I need a vertex at -2, -1, and then a p-value at -3. So lots going to be happening over here in this negative direction. So I don't need a lot over in quadrants 1 and 4. Alright, so 1, 2, 1, 2, 3, 4. Let's see here, start planning this out. So if I'm going to be at -2, and I'm going to be going 3 units more over, so I at least need to get to -5. So 1, 2, 3, 4, 5, 6, 7, 8. That should be good. Let's see here. We'll go 1, 2, 3, 4, 5 units up. 1, 2, 3, 4, 5 units down. And we'll see where we end up and see if we have to get any more space there. Okay, so my vertex is at -2, -1, so right here. Let's go ahead and label that V so I remind myself of what's going on there. And then from there, given my p-value is -3, so that means to get my focus, I'm going to go 3 in the left direction. So 1, 2, 3. All right, so this is going to be my focus. So we can see the focus as an ordered pair is going to still be at -1. Right, but what changed was the x-coordinate. So where did I end up? Well, if I was at -2, and I'm going to go 3 more in the negative direction, I ended up at -5. So there's my focus, and then as a reminder, this distance right here is p. So if we want, we could just go ahead and do the same thing in the other direction. So 3 units in the other direction. So 1, 2, 3, that'll end up there. All right, so that distance is also p. And then that would get me the directrix. A little too far over. Let's try that again. All right. All right, so the equation for the directrix, x is equal to 1. All right, so now we're going to get those other 2 special points. So for this problem, that focal width is equal to 4p. And then, as a reminder, we don't need the negative sign anymore. Okay, so this is just going to be that distance. So the focal width is going to be 12. So then 12 divided by 2, so it's going to be 6 units to get those other 2 points that I need. Okay, so these 2 points are going to be in line with the focus, and then they tell me how to extend my vertex to go ahead and complete this parabola. So I'm going to go 6 units up. So 1, 2, 3, 4, 5, 6. All right, so I get this point right here. So with relationship to my focus, that point has that same x-coordinate, right? But what changed was the y-coordinate. So if I was at -1 and I went up 6 units, I'm going to be at +5. So that gets me 1 point. And then from -1, we're going to go down 6 units. Oops, I'm going to need a couple more marks here. So 5, 6, 7, 8. Okay, so from -1, we'll go down 1, 2, 3, 4, 5, 6. So I'll end up roughly about there. Probably be easier if I actually use graph paper, so I had some lines to help me with. But this point right here again, we'll have -5 for the x-coordinate. With the y-coordinate, I was at -1. We went down 6 units, so I'll be at -7. Alright, so let's try to draw in that parabola. So from the vertex, I'm going to swing up here, grab that point, and then swing down here and grab that point. So then, just as a reminder, how did we get these 2 points? Alright, so the top point, it's going to be on this line from the focus. Alright, so I know, I'm going to try to draw this as straight as I can. I know it's going to be on that line, right? So it's going to relate to this focus. So at this point in time, because of the way this is opening, that's how I can see that I'm going to maintain that x coordinate. So the top point and the bottom point will be at -5. But what's going to happen is from the focus y coordinate of -1, to get to the top point we're going to add 6, and to get to the bottom point we're going to subtract 6. So then that's going to get me those two other ordered pairs. Alright, so that's where you'd end up -5, 5, and -5, -7. Alright, so the diagram kind of helps me visualize what's going on, so that way I don't have to memorize a bunch of stuff. I can just kind of reason through how this thing has to open and where all the other points then need to be with relationship to what I already have plotted. Alright, so maybe the last piece of information I'll put on here is just where this came from, is that this focal length is 12, so the distance from here, from the focus to the top point was 6, and the distance here from the focus to that bottom point was also 6. Alright, so there was one where we didn't have the vertex at the origin. It's opening up to the side, doing all sorts of cool stuff. Alright, so last example where we're going to be given the equation and we need to come up with the parabola and all these features on here. So for this one, it's x is equal to 2y squared minus 6y plus 7. So for this one, we are going to need to complete the square in order to see where that vertex is. So we complete the square on that squared term. So this constant, I'm going to move to the other side. And then when I go to complete the square here, remember the coefficient needs to be a 1, so I'm going to factor off this 2. So I'll be left with y squared. And if I factor off the 2, I'll be left with minus 3y, and then plus blank. Right, that's where I'm going to need to figure out what I need to have there to complete that square. Alright, so to complete the square, we're going to take that -3, divide it by 2, and square it. So I'm going to get 9/4. It's going to be what I'm going to add right here. Now whatever we added to the one side, we also have to add to the other side, but be careful. On this side, we didn't just add 9/4. We have to take into account that multiplier. So we actually added 2 times 9/4. So that's what I also have to include on the other side. And I'm just going to write it as 2 times 9/4 right now, and I'll clean that up on my next step. Okay, so then what do I get over here on this left-hand side? So I'll have x, and then let's see here. This thing that I'm going to be adding is actually going to be 9/2, but then I need to add that to the -7. Right, so -7 plus 9/2 is -14/2 plus 9/2, which is -5/2. So on this side I get x minus 5/2 is equal to, and on this side, let's go ahead and factor this. So 2 parentheses y minus 3/2 squared. Okay, so the last thing is, and then just as a reminder, when we're doing this stuff for the conics, right, so the standard form for a conic where the y is going to be the squared piece is y minus k squared is equal to 4p x minus h. Right, so the y squared term right here doesn't have this number in front. Right, so this 2, we're going to get that out of there by multiplying both sides by 1/2. So I get 1/2 parentheses x minus 5/2 is equal to y minus 3/2 squared. Alright, very cool. So we can see that the y is going to be the squared piece, so those open either left or right. But on this one, okay, since this is positive, we can see that this then is going to open to the right. Its vertex will be at 5/2, 3/2. Right, maybe to help me plot that, that's 2.5 and 1.5. Okay, so let's see what we have so far before we go any further. So I need a rightward opening parabola that's going to be at 2.5, 1.5 as its vertex. So a lot of stuff that's going to be happening over here in quadrants 1 and maybe 4, so don't need so much negative stuff. Okay, and I'm seeing lots of halves, so maybe we'll count by halves. So half 1, half 2, half 3, half 4. We'll do the same thing going up. Alright, so we'll see what that gives me so far. Okay, so 2.5, 1.5 right there roughly. Alright, so that's going to be my vertex. This thing is going to open right. So just a very generic right opening from there. Alright, so if 4p, alright, so from my generic form right here, 4p is equal to whatever is in front of this x term, which is 1/2. Solving for p, you can multiply both sides by 1/4. Alright, so then p is equal to 1/8. Alright, so this is going to be very, very small movement. Alright, so from my vertex, we're going to go 1/8 over here to get to the focus. Alright, 1/8 to the right to get the focus, and then 1/8 the other way to get to the directrix. Okay, so for this, maybe we'll just do the directrix first. Okay, so this is going to be an x equals something, but let's figure out what the x coordinate is. So the vertex was at 5/2, and we're going to back up or subtract off 1/8. So then this is going to be 20/8 minus 1/8, which gives me 19/8. Okay, so the directrix as the equation is x is equal to 19/8, or what is it, 2 3/8? If you wanted to think about it as a mixed number, how big that is. So looking at my picture here, I'm going to actually move my marker from my vertex because everything's getting real small over here, so we want to have it right next to the rest. Alright, so there's my vertex. So next thing, let's get that focus. So for the focus, as a reminder, the vertex was at 5/2 and then 3.5. So let's see what's going on. So to get from my vertex to my focus, this is going to be a movement in the x direction, nothing happening in the y, right? So this y value is going to be left alone. But in the x direction, I shifted to the right or added 1/8. So then that will then get me what my focus is. All right, so that is going to be 21/8, and then 3/2. And then again, if you wanted to figure out how big this is, it's going to be 2 5/8 and 1.5. Alright, so there's my focus. Alright, so lastly, we're going to get those two special points. So from the focus, right, we're going to go up and down. We have to figure out what these points are that are going to be on my parabola. So we need to then figure out then how far we have to go. Okay, so if the focal width, which is the same thing as 4p, is equal to 1/2. So we're going to split that in half. Alright, so as opposed to dividing by 2, we can just multiply by another 1/2, right? So that gets me 1/4. So what this is telling me, all very small movements, alright? So from this focus, we're going to go up 1/4, and we're going to go down 1/4 to get these other 2 points. Okay, so up and down, that's all y-axis movement, correct? So, come back down here, right? So that top point. So here's my focus, right? Okay, so all movement in the y direction, so the 21/8 will stay, and then the top point is going to be 3/2 plus 1/4, and that bottom point, again, x coordinate stays the same, then it's going to be 3/2 minus 1/4. Okay, so then 3/2 plus 1/4, that's going to be 6/4 plus 1/4, so that's going to give me 7/4. And then the other point was 3/2 minus 1/4, so that's 6/4 minus 1/4, or 5/4. Okay, so that was intense because lots of fractions, lots of very, very tiny movements. Okay, but we just went ahead and got these 2 ordered pairs. We'll go ahead and label them up here. So this was 21/8, 5/4 was that lower point, and then up here this was 21/8 and then 7/4. Okay, so next we're going to play a little bit of detective. What's going to happen on these next few examples is that they're going to tell me some pieces of information about my parabola, and we're going to have to come up with the equation that's going to satisfy it. So for this first one, they're going to tell me that the vertex is going to be at -2, 10, and it has a focus at -2, 6. Alright, so it is not required, but it is incredibly helpful to do a little sketch of the information that you're given so you can kind of see how everything's relating to each other. Alright, so here's -2, 10, whatever, it doesn't need to be to scale. There's my vertex. So maybe I'll go ahead and label it too. And the focus is at -2 and then 6. Alright, so there's my focus. So remember, the parabolas and all conic sections eat their focus. Right? So here's where I can see then this is going to have to be a downward opening parabola. Who knows where it intersects the x-axis or even the y-axis. We don't really care at this point. We're just trying to get an idea of what's happening here. Okay. Alright, so first thing that's going to be useful is when I have parabolas that open down, which variable is squared, the x or the y? The x, right? The x is going to be the one that's squared. Okay. X squared, those ones open up or down. The y squareds open left or right. So here's my general structure. X minus h squared is equal to 4p parentheses y minus k. Now they gave me the vertex. Right? Vertex is at -2, 10. So there's your h, there's your k. So in order to complete this, the only other piece of information I need is p. Now, as a reminder, p is the distance between the vertex and the focus. All right, so this distance right here from the vertex to the focus, that is going to be the value for p. And in this case, because I'm going down to get to my focus, that value is actually going to be negative, right? And I'm going from 10 to 6, so that's a shift of 4 units. Okay, so now I have everything I need in order to fill this in. So it's going to be x minus, my h value is -2, squared is equal to 4, and then my value for p is -4, and then y minus 10. All right, so to finish this up, we'll just clean that up. I'm going to get negative 16 for this multiplier out in front, and there is my equation. All right, so next one, they're going to tell me that the focus is at negative 3 comma negative 2, and the directrix is at y is equal to 1. All right, so again, sketches are helpful. All right, so negative 3, negative 2, here's my focus, and the directrix is at y is equal to 1. Okay, so maybe I'll go ahead and put a tick mark right there. All right, so there's my directrix. All right, so first big question, how does this thing open? Left, right, up, down, what's going on here? So remember, it's never going to cross your directrix, right? And then how it curves is it has to eat your focus. So this thing has to open down. So if it's opening down, what does that generic form look like for the conic? Is the x going to be squared or the y going to be squared? The x is going to be squared, right? So x minus h squared is equal to 4py minus k. All right, so fun fact for us to remember. The vertex is halfway between the focus and the directrix. I don't think that was spelled right. Directrix. All right, there we go. Okay, so if my focus is at negative 3 comma negative 2, and then my directrix is at y is equal to 1, right? To get from one to the other, it's all movement in the y-axis. Right, so this distance right here is 3. Okay, so we're going to find half of that. And then that tells me how much I need to move to get to my vertex. So, alright, so from the focus to the vertex is going to be halfway, right? So it's going to probably live somewhere right about there. Alright, so to get to that vertex, the x-coordinate isn't moving. Right? So the x-coordinate is still going to be negative 3. What's happening is the shift to the y-coordinate. Right, so from negative 2, which is where the focus is, we're going to go up, add 3/2. So this is then going to give me negative 3, comma, and then negative 2 plus 1/2, that's negative 1/2. Alright, so there is my vertex. Alright, so I can see my HK that I'll use in this generic form. The only other thing I need that value for P. A couple ways that you could get it, but perhaps in my mind one of the easiest ways is to really just keep coming back to the fact that P is the distance between your vertex and your focus, right? So that distance is P. So if I'm going from, let me rewrite these ordered pairs out. If I'm going from negative 3, negative 1/2 to negative 3, negative 2, how much these y-coordinates change is going to be my value for P. The other thing to notice is that P will be negative. Right? So because from the vertex to the focus, we had to go down to get it. So to find out how far I moved, let's just subtract those two values. Okay, so -2 minus -1/2. It's the same thing as -2 plus 1/2, or -1/2. Sorry, -1 and 1/2, which is the same thing as -3/2, if you want to write it improper. Alright, we have everything we need. Let's go ahead and start filling in our pieces. Alright, so it's going to be x minus -3 squared is equal to 4. My value for p is -3/2. Y minus -1/2. So cleaning this up, x plus 3 squared is equal to, all right, that's going to give me, what is it, -6 y plus 1/2. All right, so there is our equation. All right, last example. Vertex is going to be at 3, -2. Axis of symmetry, we haven't talked a lot about that, but we're telling me the axis of symmetry is going to be parallel to the x-axis, and the y-intercept is going to be at 1. We haven't been talking a lot about intercepts, so how is that going to come into play? Well, let's go ahead and find out. Okay, so we're trying to come up with this equation. So, they've given me my HK, so, we'll say thank you for that. Let's figure out what I have so far. So 3, -2, 1, 2, 3, down 2. Right, so there's going to be my vertex. And they're telling me the axis of symmetry is going to be parallel to the x-axis. So here's my x-axis right here. So the axis of symmetry for this guy apparently has to be this, right? It's the fold line for the parabola. The vertex lives on the axis of symmetry. So, I mean, they didn't ask me for it, but apparently this axis of symmetry is y is equal to -2. Because my vertex is at 3, -2. So from this, which way is the parabola going to be opening then? It's going to go open down or left and right? Well, this is going to be my axis of symmetry, right? That's going to kind of split my parabola in half. This thing either has to open left or right. Right? So this is going to be that the the y value is going to be squared. So generically, okay, so this thing is going to open either left or right, just by the information I have seen so far. So this is going to look generally like y minus k squared is equal to 4p x minus h. Now I haven't yet plotted that y-intercept, so maybe I'll go ahead and put that down. Right, so my y-intercept is going to be at 0, 1. So go ahead and plot that. Okay, so if this thing either has to open left or right, the vertex is going to be either that farthest point left or farthest point right, depending on how it opens, and it's got to contain this point. Right, so here's where I'm starting to see then, yep, this is actually going to open to the left. So I can see this is going to be a leftward opening parabola. Now they gave me that vertex, my HK, so maybe we'll go ahead and put that information in since I already have it. So for my k being -2, I'm going to get y minus -2, or y plus 2 squared, is equal to 4px minus 3. So at this point in time, I just need to get that value for p. Now normally we use things like the focus or the directrix and things like that to get that value for p. If I even had that focal width, maybe I could use that, but I don't really have any of that information, right? But they told me that the y-intercept is at 1, so that's at the ordered pair 0, 1. So that's information, right? Like that's telling me for this equation, if x is 0, then the value for y is 1. So let's go ahead and use that. Right? If I plug that into here, okay, so y is 1, so 1 plus 2 squared is equal to 4p, 0 minus 3. Okay, the only thing that I don't know then is p, and I can solve for it. So this is going to give me 3 squared is equal to 4p times -3. So 9 is equal to 4p times negative 3. Now, if you wanted to, you could multiply that out. But remember, I don't really want to know what p is. I want to know what 4p is. Right? That's what I'm going to substitute back into the equation right here in order to finish this. So I'm just going to leave this 4p chunk of information alone. So just get rid of that negative 3 that I don't want on that side. So I get negative 3 is equal to 4p. Alright, so then that's going to wrap up my equation. So I'm going to have y plus 2 squared is equal to negative 3x minus 3. And it makes sense that that value should be negative because this vertex is going to be opening up to the left. Alright, so that concludes our analysis of the parabola. Next conic section we look at is the ellipse, but definitely spend some time with this parabola stuff. There's a lot going on, a lot of new vocab and relationships. Again, don't sit and memorize tables. Just spend some time doing sketches and kind of analyzing the way things have to move, and just know some fundamentals about the distances that need to be satisfied in order to be able to get some of the points and lines and things like that that's going on with these parabolas.